Okay, so how is everyone today? Good, I hope. The deadline I set for the graders to grade the thing is today. So I've been waiting on one grader. Two of them were quick. The other one is waiting to the deadline. So it should be done today and posted and visible for you. I see the date is the 21st of March. That's great because that means we're right on top of the what astronomical event? The equinox, right? Which means that this is the time of the year when the number of seconds of daylight is the same as the number of seconds as nighttime. Great. Okay. So last time we were talking about we were talking about factoring quadratic expressions. So let's do one more of those, and then we'll move on to the next thing. So the request is please factor 5t squared minus 4 t plus 9. And with the additional clause that this is in C. So perform this action in the complex numbers. All right. Good. So we factored quadratic things at the beginning of the semester. And generally speaking, the things that we learn at the beginning are easier than they become more difficult as you go on. So you should always ask, can you do this the easy way? Which is to say, is it possible to find two numbers whose product is, what product would we be looking for? 45, because it's the product of the first and the last coefficient. So we want two numbers whose product is 45, and what do we want their sum to be? -4. So can you think of two numbers that will do this, whose product is 45 and whose sum is -4? Can you think of two? This exercise has just a little bit. Well, yeah, they're not integers, but wait a second. Isn't it true that -9 and 5 add to be -4? Ah, right. But then it wouldn't have the correct product. But what I want you to see is that it's a little bit of poison there, I guess you might say. -9 and 5, they add to be this, and they multiply to be negative that. So there's, on a question like this, many students will take the bait. What I'm trying to remind you of is you have to carefully check that both of these conditions are true. Okay, so there is none. Also, I want to point out that the kind of thing that this is, this math thing that we're looking at, well, in the first place, it's a polynomial. And because it's degree 2, we refer to it as a quadratic. And generally speaking, the kind of thing that it is, it's just an expression. It's something that you could plug stuff into and evaluate it. So the kind of thing that this is a quadratic expression. Also, I want to point out again that if you take a look at what you've copied down, and if it looks like this, 5t squared minus 4t plus 9, then you need to stop that. Okay, that's we're adults here, and this is a math class, and it's just not permissible for your t's to look exactly like your pluses. Okay, good. So this makes the grader and the instructor sad. Okay, so don't do that. Good. So we can't do it the easy way. Yes? Do you have a question?
Yeah, I'm sorry. Tell me again what makes it the quadratic expression. expression because ultimately, with the way we did it the other day, it ends up with 4 possible answers or however you get.
Well, okay. So it's sort of a quirk of history. The reason why it's called this. So we have the phrase x times x is x squared. Because if you were to take a rectangle that has side 5 and so like height 5 and width 5, then that is not just a rectangle, it's called a square. And its area is 5 times 5, and so as a result we refer to that as 5 squared. The four-sidedness of rectangles is where quad comes from. But in the end, quadratic means polynomial whose degree is 2. Which I think
seems kind of counterintuitive because of the word quad.
Right, but that's what it means. But the connection is that when to find the area of a square, you square a number, and it's called an expression because an expression is any old thing that you plug stuff into. Like we could plug in t is 8, for example. Fine. So then, can we factor this quadratic expression easily? No, we can't. As a result, we're going to do something that I hope you see is kind of odd. Instead, we're going to solve an equation. What we're going to do is we're going to take that quadratic expression, 5t squared minus 4t plus 9, and we're going to put it in an equation with the other side equal to 0. So now this thing, this is called a quadratic equation. It's an equation because, well, the left-hand side is an expression, the right-hand side is an expression, and it's got an equal in the middle. That's why it's an equation. It's a quadratic equation because that is a quadratic expression. But these things, while definitely related, are not the same thing. So I want to point out to you that this is a little bit strange. It's like saying, well, I want you to do something with this quadratic expression, and at the present time you're saying, you know what, I understood what you said, but forget it. I'm not going to do it. I'm going to do this other thing because I don't like what you asked. We'll do this. So it's a little strange. Every quadratic equation can be solved with the quadratic formula. So we'll use the quadratic formula. The coefficients in this exercise are 5. A is 5, B is -4, and C is 9. The quadratic formula says that there'll be 2 solutions. One of the possibilities would be negative B, so -4, subtract square root of. Now the stuff that goes in the radical, the stuff that goes in the square root, is so important that it itself has its own name. What's the name of the stuff that goes in the square root? Discriminant. Okay, so that would be b squared minus 4ac. So -4 squared minus 4 multiplied by 5 multiplied by 9. That's what goes in there. And then over 2a. So 2 times 5. All right, that's one of the possibilities. What's the other possibility? Right. Same exact thing, except instead of subtract square root of discriminant, you add square root of discriminant. So, or the other possibility is t is, oops. -4 add the square root of -4 squared minus 4 times 5 times 9 all over 2 times 5. So simplifying a little bit, -4 is 4, so this will be 4 subtract square root of something I'll do with my calculator in a second over 10, or t is 4 plus square root of that same something over 10. All right, so I won't try to do that much arithmetic in my head. The discriminant is negative 164. Okay, now there should be a moment of pause and reflection here. Why?
Because if you hadn't said that it's in C, then we would be able to stop.
Yeah, right. So then there's a negative inside of a square root. And that raises the question, is it permissible to proceed? It is, because we said that we're doing all these operations in the complex numbers. If the NC thingy wasn't there, then you could just stop right here and say it's prime. It doesn't factor. Okay, but we can proceed, so we must. The negative can come out of the square root, and what does negative come out of square root as? Comes out as I. So then it would be t is, one of the possibilities is t is 4 minus square root 164 multiplied by I over 10. The other possibility is that t is 4 plus the square root of 164. Negative has come out as I over 10. Okay, so is this the answer to the exercise? No, right? What I'd like to point out is that from a certain point of view, it kind of seems like that you've done nonsense, right? I said, I want you to factor this expression. And you said, yeah, I see your expression there, but I'm actually going to solve an equation. Because I don't even like expressions. You know, I don't know, you know, who knows? What do these solutions have to do with the factoring that expression?
The solutions are related to the factors, which are related to the thing that I can't remember.
Right. So the quadratic formula says that quadratic equations have two solutions. Here they are. How many factors are there going to be? 2. Is it a coincidence that there's going to be 2 factors for this expression and that there are 2 solutions to this equation? No, it's not a coincidence. That's the whole point. That's the whole point, is that factors correspond to solutions. That's the whole point of doing this side work here. As a result, we know that 5t squared minus 4t plus 9 should factor in the following way. It should be t subtract some slot, right? And then multiplied by t subtract some other slot. I think the pattern is going to look like this. What goes in the slots? The solutions, right? So it's t minus one solution multiplied by t minus other solution. So those go in there. 4 minus square root of 164 multiplied by I over 10. 4 plus square root 164 multiplied by I over 10. Okay, so the work so far has been good work and it's correct, but the answer is not correct yet. What's not right? Right, correct. Right, the leading coefficient. Because, these numbers, 4 minus the square root of 164 multiplied by I over 10 and the other one, they're kind of obnoxious. But in principle, right, this is a binomial and that's a binomial. So in principle, you could FOIL that out. And if you were to do that right now, as it's written, the f term would be what? T squared. That, which is to say 1 t squared. But we don't need 1 t squared. We need 5 t squared. So the answer is 5 multiplied by that. And that's what we did last time. Any question about these things? Okay, let's go on to new things. So now we're going to talk about equations. So I'll say I need to back up just slightly and remind you of something that we already talked about. And that is to say that equations evaluate to a logical value. Which is to say, true or false. So we talked about this at the beginning, more near the beginning of the semester. And some of you were surprised to hear me say that 7 equal to 10, 7 equal 10, that's an equation. It is. What's its logical value? False. That doesn't mean it's not an equation. It is. It's just that its logical value is false. And that doesn't make it immoral or unethical or anything like that. It's just an equation whose logical value happens to be false. And 8 equal 8 is also an equation. What's its logical value? True. Okay. Now we can begin this remark. I can say let A, B, and C be in the reals, and let A equal B be an equation. And understand what I mean by that. I'm not saying that A equal B, its logical value is true. I'm saying that it's just an equation. Its logical value could be true or false. The first statement is that adding C to both sides of an equation preserves the logical value. Okay, so that's kind of a... If there were ever a mathematician sentence, there it is. So let's try and make it clear. The equation 13 equal 13. Well, it's an equation because, after all, an equation is two expressions, one referred to as the left-hand side, the other the right-hand side, and then an equal in the middle. So it's an equation. What's its logical value? True. Suppose we add something to both sides. Suppose we add negative 5, which is just sort of a strange way to say subtract 5, but it's fine. So we'll add negative 5 to both sides. What's the new left-hand side? 8. And what's the new right-hand side? 8. What's the logical value of this equation? True. What that sentence above is saying is that, well, we started with an equation whose logical value was true. And then we added something to both sides, and the resulting equation's logical value was also true. These are the same. Similarly, here's an equation, 13 equal 14. That's an equation. What's its logical value? False. Suppose that we add something to both sides. I'll add, I don't know, it doesn't matter, 2. I'll add 2 to both sides. The new left-hand side is 15, and the new right-hand side is 16. And what's that equation's logical value? Still false. And what that sentence above is saying is what you're witnessing here. Is that in this case, we started with an equation whose logical value was true. We added the same thing to both sides, and the resulting logical value was still true. Here we started with an equation whose logical value was false. We added the same thing to both sides, and the logical value was still false. Started true, ended true, started false, ended false. It is always permissible to add or subtract the same value from both sides of an equation, and you will not modify the logical value. Great. So that's probably not surprising, honestly. So multiplying both sides by C preserves the logical value So far it's like exactly the same sentence, more or less, substituting add for multiply, but now I have to add an additional condition, as long as, and then now I'll leave a blank, and let's see if we can figure out what it is. Yes?
C is not 0.
Ah, good. Okay. So let's see why. Fine. So then 13 equal 13. That's true. And so we could multiply both sides by, I don't know, 5. That'd be neat. If we do that, then the new left-hand side is 65, and the new right-hand side is 65. The resulting equation is true, and notably, the truth value is preserved. That's good. 13 equal 14. That's an equation whose logical value is false. If we multiply both sides by any number that, well, almost any number here, I'll multiply by, I don't know, half. That sounds great. Multiply by half. Both sides. So the new left-hand side is 6.5, and the new right-hand side is 7. And of course, that's false. Notably, the logical value is the same. But, right? To sort of motivate the reason, the punchline that we're coming to was already said out loud, but I want to make sure it's clear. Going this way, we're adding 2, right? Add 2. What's going this way? What's the subtracting 2, right? You could subtract 2 from both sides, add 2, right? Adding -5, subtracting -5. So they're, adding and subtracting are inverse to each other. This is multiplying. What's the inverse of multiplying? Dividing. And then, is it always permissible to divide by any number that you like? No, right? Division by 0 is not going to work. Same problem here. So how about 13 equal 14? That's an equation. Its logical value is false. Suppose we multiply both sides by 0. What's the new left-hand side? 0. What's the new right-hand side? 0. That's an equation. What's its logical value? True. And here I want you to witness. We have performed an operation on an equation that has modified the logical value. So this is, kaboom. Universe exploded. The reason, in the end, if you like, to connect it to some other knowledge that you have, is that, yes, going this way, that's multiplying by 0. But going this way, the opposite of multiplying is dividing, so going that way is dividing by 0. That's what's happening here. It's just not permissible to do it. Also, every time I write 0 equals 0, I think of an oxygen molecule. Right? Because that's the way you write it in chemistry. Okay, fine. So the condition is that you can multiply both sides by a real, as long as this real is not 0. Any question about this? Okay, so another thing that we want to be able to do safely. So this is a continuation of the previous page. So squaring both sides. Of an equation. Squaring both sides of an equation preserves the logical value. And again, there's a condition. As long as, I'll leave myself a blank. Okay, so 13 equal 13. An equation that is true. Suppose we want to square both sides. What is the punctuation for exponents? Caret, right? So like this. We want to square both sides. What is 13 squared? 169. So the new left-hand side is 169. The new right-hand side is 169. The first equation was true. The last equation was true. So in this case, the logical value has been preserved. Another one. How about 13 equal 14? But for reasons that I hope are foreshadowing, I'm going to not do 13 equal 14. I'm going to do negative 13 equal 14. So of course that's false. And I'm going to square both sides. So square, square. What is the left-hand side? 169. But wait a minute. 169, what happened to the negative? Ah, yeah, when you square, the negative goes away. So then 14 squared is 196. And this is also false. So what I want you to observe is that we took an equation that was true. We squared both sides and the result was true. We took an equation that was false. We squared both sides and the result was false. So that seems to be working great. But we can break it. What will break this? Ah, right. So what about this equation? Negative 13 equal 13. So is that what's that equation's logical value? It's false. Because obviously negative 13 is not 13. But if we square both sides, well, what's negative 13 squared? 169. And 13 squared? 169. And that, of course, is true. So I want you to observe that squaring both sides of an equation, this has modified the logical value from false to true. And just like on the previous page, we noted that, well, going this way is adding. And for this one, going that way is subtracting. So we've got add and subtract. This is multiply and divide. Going this way, multiply by 5. This way, divide by 5. What is the inverse operation of squaring? Square root. As a result, if squaring has a problem, square root has a problem. Right? So the condition is, so I'm not, I'll say it out loud. The problem here is that the left-hand sides are not the same, but they have the same magnitude and the opposite sign. So what I mean is that this is 13 in the negative sense, and this is 13 in the positive sense. Negative 13 and positive 13. Obviously, those aren't the same. But when you square them, the result is the same. So this would work just fine for negative 14 and positive 14 and a lot of other things you can imagine. So I'll just say, as long as we avoid this kind of situation.
So could you say that, I was thinking in my head that it would be as long as A and B are greater than 0. Is that correct?
That is true, but we'd also want the case that they're both. We'd also want to have the case that they could both be less than 0. So we
negative 13 is less than 0.
Right. So then, and if I were to modify this one to say negative 13 equal negative 13, it would still, this would still be true, and that would still be true, and we like that. Okay. So where does this? How does this come up? So what I'm going to do is I'm going to walk you through the construction of an exercise. We won't have time to solve it today, but I want you to see how it's made, because if you can understand how it's made, you can understand how it can be unmade. So this is me back in my office conspiring to make you an interesting exercise. So I'll choose 2 numbers. I'll make them integers because fractions would just muddy the waters. I'll take one of them to be negative and the other to be positive. How about negative 3 and 8? So I make those selections. Then corresponding to these, I'll come up with a quadratic expression. X plus 3 multiplied by x minus 8. The reason why I like this, why the quadratic expression corresponds to these choices, is that notice that when you plug in x is negative 3, that one is 0. So the whole product would be 0. And when you plug in 8, that one would be 0, so the whole product is 0. Okay, so I'll multiply this out and collect like terms. X squared minus 5x minus 24. So now I'll consider the corresponding quadratic equation. X squared minus 5x minus 24 equals 0. And again, this is me back in my office making an exercise. So I'm going to get the x squared by itself. I'm going to move the other terms to the other side. X squared is 5x plus 24. And now I'm going to do something that is slippery, right? Something that you have to take caution when you do it. I'm going to compute the square root of both sides. And I want you to notice that on the previous page we just got finished saying that squaring both sides and computing square root of both sides is a little bit questionable. So now, the right-hand side is still square root of 5x plus 24. And I want to simplify the left-hand side. What does the left-hand side simplify to? Absolute value of x, right? Not x. I wish I had my button here. Click. Right, click. That's the 36th time I've said that the square root of x squared is absolute value of x. Okay. So the absolute value is often forgotten by students. So now, again, this is all hidden from view. Here's the exercise. Please solve x equal to the square root of 5x plus 24. Now, conspicuously absent is what? The absolute value. The point of this exercise. This is not the statement of the exercise. This is me telling you what the point of the exercise is what will the student do with the absolute value, which is missing? What will happen? So what I'm going to give you now is a little bit of discussion. It's not a solution, but it's a little bit of discussion so that you can understand the pitfall and the specific thing that I'm checking for. So because this is visible, you know that -3 and 8 have something to do with the answer to the question, right? Surely they do, because those are the things that I chose. So notice that if you plug in x is equal to 8, both sides, the left-hand side will be 8, and the right-hand side will be square root of 5 times 8 plus 24. And what's the square root of 5 times 8 plus 24? Well, what is 5 times 8 plus 24? 64. And what's the square root of 64? 8. So there's an equation. Is it true? It's true. At x equal to -3, and again, this is not the solution. If you plug in -3 to both sides, you obtain the equation -3 is equal to square root of 5 multiply -3 plus 24. Well, 5 multiply -3 is -15. Add 24 is 9. So this would be -3 equals square root 9. And what is the square root of 9? 3. So here's an equation. Is it true? Is false. But if you square both sides, the result would be true, right? So here's what's going to happen next week. I'm going to predict the future. On Friday, I'm going to give you. We're going to solve things like this, a bunch of them. Then next week you're going to have a corresponding quiz exercise. 4 or 5 of you that are listening to me right now will have no idea how to solve the exercise. Another 4 or 5 of you, maybe up to 10 of you, will be able to determine that 8 and -3, they'll be different, but 8 and -3 are important, but you'll think that -3 is a solution. And then the rest of you will be able to solve it correctly. So I'm telling you right now, I'm telling you the game that I'm playing. Okay? Good. Any questions about it? Again, this isn't a solution. I'm just telling you what's going to happen.
My question is, how do I want to be in the category the last one.
The last one.
How do I do that?
We're going to solve so many of them on Friday. So the answer is coming on Friday. This is like me saying, if we were all marching down the road and I took the time to say, now look, there's an enormous pothole that's 100 feet up there. And I want you all to watch carefully how I walk around it. This is me telling you it's coming. And we're going to talk all about it on Friday. Good. Okay, let's have 2 quizzes, actually.